Just a few kilometres from the city centre of Los Angeles, California, is one of the most important fossil sites ever discovered, the Brea Tar Pits. And those pits trapped an amazing array of animals from the end of the last ice age. Giant Columbian mammoths, an American lion, 2 species of oversized bison, giant ground sloths like this one, an immensely powerful animal, but still no match for the tar. And because those fossils ended up in the tar, they were exceptionally well preserved. In combination with radiocarbon dates and atmospheric records from Antarctic ice cores, the fossils hold a unique record of a major extinction event during a period of rapid climate change. The area sits above naturally occurring oil deposits, and in the early 1900s the area was a producing oil field. But long before humans drilled for oil, some of it leaked to the surface through natural faults in the overlying rock. The oil pooled in low areas on the surface, and the lighter fractions of the oil evaporated, leaving a sticky black tar behind. Rainwater and falling leaves covered the tar, setting a merciless trap. Animals walking over the pools quickly became stuck. Once in the grip of the tar, there was no escape. The more they struggled, the deeper they sank. Strength was no defence. Even mighty mastodons were eventually exhausted. Unable to move, they became easy targets for predators like saber-toothed cats. But the easy meal for many predators would be their last, as they too were trapped in the tar. The stench of their rotting bodies laid yet another trap for scavengers like dire wolves and eagles. Fighting over the rotting carcasses, they also met a sticky end in the tar. The 9-to-1 ratio of predator to herbivore fossils in the pits shows just how effective the baited traps were. The number of carnivores that fell into those pits to get the rotting carcasses of the herbivores is truly impressive. Every one of these is the skull of a dire wolf that met a very dire end. As their flesh decomposed, their bones sank into the tar, preserving them and protecting them from the ravages of oxygen, sunlight and bacteria. Some of the pits would eventually be covered by layers of sediment deposited by floods, but a few remained open to the present day. When Europeans began settling in the area, they found uses for the tar, in waterproofing roofs and making asphalt roads. When asphalt mining ceased, the pits filled with water, but oil and methane are still bubbling to the surface in some of those pools today. Some of the pits have been reopened for research purposes, and new buried tar pits have been discovered by recent construction work, so the site is still yielding a wealth of fossil remains. The bones in the tar were originally thought to be from cattle and other farm animals, but in 1901 Union Oil geologist William Orcutt recognised them as fossils. The site is critically important because it records the extinction of the American megafauna in great detail. Fortunately, the period covered by the tar pits is also within the time window where radiocarbon dating works really well, so it's possible to get very accurate dates for the fossils. Recent radiocarbon dating has shown that most of the megafauna fossils are around 12 to 14,000 years old. The La Brea events are also within the period covered by the ice cores from Antarctica, so we have very detailed data about the temperature and CO2 in the atmosphere at the time the megafauna died out. This plot of atmospheric temperature based on oxygen isotope data is from the Dome C core, which is the most useful in this case because it covers the entire La Brea period in a single core. The temperature is on the left axis in degrees C away from the average from the last 1,000 years. The horizontal time axis is relative to the present day, which is standardised on the year 1950. The extinction occurred during a period of rapid warming from the last glacial maximum to the interglacial period that we're in now. We're technically still in an ice age because there are permanent ice sheets on both poles. The temperature rose nearly 6 degrees over a period of about 3,000 years, peaking around 14,000 years ago. Plant fossils from the tar pits and nearby lakes indicate that the vegetation changed from dense wet forests of junipers and oaks to open dry grasslands during that 3,000 year warming period. Then, just as the temperature began to fall back a little around 13,200 years ago, humans arrived, having crossed the Bering Strait from Asia during the low sea levels at the last glacial maximum. Just 300 years after those humans arrived, almost all of the American megafauna species were gone. The precise fossil record of those events in the Brea Tar Pits makes them a treasure trove of information about the way ecosystems and humans responded to rapid climate change. In most other locations, large land animals are very rarely preserved as fossils because their bodies get eaten by scavengers and destroyed by the effects of weather. As a result, it's often very difficult to identify the exact time that a species died out. But the Brea Tar Pits were so effective at trapping animals and so good at preserving their remains that there's literally a calendar of extinctions. Academic debate has raged for decades over whether the megafauna were hunted to extinction by the newly arrived humans or were simply unable to adapt to the rapidly changing environment. Recent research published by staff at the Page Museum has suggested that fires started by humans and accelerated by hotter, drier climate conditions were the nail in the coffin for the megafauna. The climate change in this case clearly wasn't caused by burning fossil fuels. The Industrial Revolution was still more than 10,000 years away, but the magnitude of the temperature jump is something similar to that being predicted by the more pessimistic models of future human-induced global warming. Clearly a change of that magnitude would have serious consequences for humanity. But there's also an important lesson in the Brea story about how we might respond. Humans didn't go extinct with the megafauna. In fact, they flourished alongside modern bison and other species that were better able to adapt. Given the difficulty of getting every country in the world to agree on and implement drastic reductions in fossil carbon emissions, preparing to adapt might be a more prudent strategy. To put this in context of the current climate debate, I'll add the CO2 data from the Antarctic ice core, the modern atmospheric CO2 measurements, and the satellite-based global temperature measurements. The scale for the CO2 concentration is in parts per million on the right. Since we started burning the oil that made the tar pits, there's clearly been a sudden jump in the amount of CO2 in the atmosphere. And the isotopic signature of the carbon in that CO2 suggests that it probably came from fossil fuels. There's still some question about whether CO2 drives temperature change or vice versa. You can see it lags behind temperature in most of the chart. Now that might be because temperature isn't driven by CO2, or there might be a time lag in the CO2 data from the ice cores. But that's a subject for a whole other video. If we zoom in to the most recent 1,000 years, you can see that this time the CO2 leads temperature. Temperature does appear to be responding, but the size of the change and the rate of the climb are not yet outside the noise range in the ice core data. To illustrate just one reason why there's still debate on this issue, here's the temperature data compiled from 6 ice cores in the Greenland ice sheet. It doesn't go back quite far enough to cover the Brea events, and it's from the other end of the Earth. But you can see that there's still some work to be done in correlating the timing of events and understanding if global temperatures were rising or falling. The underlying message from the Brea Tar Pits is that if we want to understand the impacts that humans are having on climate today and what the consequences might be, then the fossil record is a great place to look for baseline data.